Okay, yes, tonight. All right, guys, quickly, let's run through. Guys, please leave Noella alone. She's special. All right, 2.1. I don't think anyone here, the only reason I chose to do 2.1 is just the algebra that is there. And the algebra is that people forget to put a bracket. That's all I'm looking at. When I see that, I know that number 1, T2 minus T1 should be what? T3 minus what? T2. So I'm going to run. What is that? 2x plus 1 minus. This is where the error is that I'm trying to. I think I spoke about this last week. I don't know. Somewhere. What is T3? 4x minus 1 minus. Okay, please, what's the value of x? That's the only thing I want to emphasize. What's your value of x? X is 6. Thank you. How we got there? Ask a grade 8 learner. Calculate the numerical value of the 7th term. All right. The 7th term, what will be our first term? 3. Second one? 13. You sure? And then next? It's an arithmetic pattern, right? Good. What's our difference? Our difference is 10. I told you, leave all those grade 8 things. Okay? We put a minus there. We get our Tn straight. What's our Tn? 10n minus 7. All right. My grade 8 are doing this. Now grade 12 is writing Tn equals to a plus. Forget that thing. Please. Move it. You get your full marks here. But what are we looking for? T what? 7. What would that be? 10. Please show that substitution. All that be 70, I think. I'm lying. 63. Okay, done. Please, those are just, even this one, guys, I don't think I'm going to do the whole thing. I'm only interested in the last question. So please, in case you didn't get whatever answer we are given, let me know. Guys, 2.2.1? Let's confirm. Okay, those of us at home, then say your face. What did you get? 44, 46? Always use your TN. For me, that's what I do. I don't want to do two job at this, I'm going to do 2.2 first and go back. It helps me. But always test to see if it works. 46. What is TN? 2n squared?
Minus n.
Minus?
N. Last one.
Did you get? Now, so if you got the second one, if you got this, there's no way you should get this wrong. All you just need to do is to say 50 and put a 5 there and then go back. All right. Now, show that the sum, okay. Are you guys doing my proofs though? I didn't send the proof today. Right now I've sent 4. 2 Euclidean and 2 arithmetic. Please, let's do those proofs. 29
plus 15.
You still getting 44?
Yeah.
Okay, all right. Let's check. But if you put a 5 there, are you getting 44?
That's 15.
Yeah.
That's not 15. The difference is 4. 13.
Okay, Noella, you are here. Yes. Already they are saying you are special. So let's prove to them that you're special. Okay, what's our difference here? 5, 11. Oh, 9. So I'm tired. 9. 13, right?
Yeah. Then 17.
It's not 15. It's 17.
The difference is 13 plus.
Maybe you said 2 there, maybe. Yeah. The difference here is 4. 4. So this should be what? 46. Okay, guys. Show that the sum of the first differences. The thing is, your first difference is an arithmetic, right? So what do we know? Yes, talk to me. Am I getting a hand there? Yes, talk to me there. Quickly, Michelle. Hi.
You're speaking too fast.
I'm speaking too fast. Because I'm here, I'm expecting you to... Did you get them wrong?
No, sir.
Yes, this one I want to fly over. Remember, this one is, I'm just greeting you with this question, saying welcome today. So I don't want to waste time on this one. We have lots of things to do. So this one, I think the only thing I want to do is 2.2.4. That's the only thing I really want to do. So all of this, Michelle, I'm expecting you're just marking. You see, I'm not even doing the questions. 2.2.3. Sn equals to what? N over 2. 2a plus n minus 1d. It says the first what? Show that the sum of the first differences. All right. So we don't know n. But do we know a? Of the first difference. Remember where my first difference is. My first difference is that. So what is my a? What is my a there? 5 plus n minus 1, and our constant difference is what? 4. Let's simplify this. N over 2. What would that give me? 10 plus 4n minus 4, which is n over 2, 10 minus 4 is what? 6. And if we expand that, will that give us 2n squared? Yes. 2n squared plus 3n. Okay, guys, 2.2.4 is where I want to just pause a little bit. If the sum of the first 40 differences in question 2.2.3 equals 3320, that is S40. Can I just show you something here? Look at what the examiner is telling you here. It's a very simple thing. Guys, let's use simple numbers. What is 5 plus 9? 14. So I have used check 5 plus 9. What's the next quadratic? Look at that. If you add these 3 together, you'll get 16. Okay, let's go back again. Let's re-explain. What is 5 plus 9 plus 13? 5 plus 9 is 14. 14 plus 13 plus the first 2. I'll go to the next one. So again, 5 plus 9 plus 13, because check, 2 plus 5 would give you 7. So it's just 2 plus 5 now, which is, wait, so you see it. Where is this 7? It's already 2 and 5. 2 plus 5, which is 7, plus 9 would give me 16. Now, 2 plus 5 plus 9 is already what? 16. Add the next to it, I'll get 29. So it's a matter of just walking that way. Wait, how would you have gotten 46? Add all of this together. Plus 2. So it's just a system there. What will we then do to get 2.2.4? Yes, talk to me, Michelle.
So does this apply for all quadratic equations?
Yes, it's the same system. All quadratic. Go and test it. It's going to work because they're just using mathematics here. Because how do you get 7? It's 2 plus 5. Then what do you do to get 16? You add 9. So this is your 7 plus 9. Then you move on like that. Now, the examiner says if the sum of the first 40 differences is equal to 3320. Let's come back here. The sum of the first 2 is what? 14. All right? 1, 2. If I add this one to it, it will give me term number 3. So the first 2 plus this, term 3. The first 3 plus the first term, term 4. The first 4 plus my that would give me what? Term 5. Do you notice? 3320 plus 2 will give me what? 3322. So what's your answer? It's 41. 41. I don't know if it makes sense, guys. First 2 plus this first one would give me the third number. First 3 plus 2 would give me the fourth number. First 4 plus 2 would give me the fifth number. So first 40 plus 2 would give me, it doesn't even need any calculation. Answer is T what? 41.
So if we just always
Yeah, there's no, you don't need any calculation. T 41. What calculation am I going to do?
Do maybe the quadratic.
No, you don't. Even if you want to do calculation, they told you check. What is Sn?
Yeah.
What?
One is wrong, sir.
Oh, really?
You can prove it.
What did you do? Okay, what did you do?
I made it a quadratic. So basically I said 2n squared plus 3n equals to 3,308.
Yes.
Then I substituted. Then I took it to the outside, it became a positive, right? Then I divided by 2. Then I did my quadratic equation. Then 41 here, n is equals to 41,5. The correct answer is 40.
The correct answer is 40.
Yes, you can try what I'm saying here.
Okay, if you are using quadratic, you are going to get 2 answers, right?
Yes.
And you got 40 and 41,5.
Yes. Negative 41,5.
And what?
And 40.
Okay, please read the question. You see, you are getting 40. Already they've given you the 40. That's the 40 you got. So 40 is not the answer. No, boy. Please understand the question. The question says, which term in the quadratic sequence? Okay, I want to prove that you are wrong.
No, sir. When you do the quadratic, you get 2 answers.
Yes.
One is 41, the other one is negative 41.
No, guys, please listen.
Oh.
Listen to, when they gave you the sum here, we are mixed. What is this sum? It is the sum of the first what? Differences. It means when you add 40 of the first differences together, you will get 3,320. Okay, very easy. Let's confirm. Please put 41 here for me. Done. So please understand the question. The question is not asking you for anything that has to do with the first difference. And that was why, please, let me re-explain. That was why I tried to give you this sequence. We had 2, we had what? 7, we had 16. What's the next one? 29. Please understand what the whole thing is. What's your difference here? 5. What's the difference here? 9. What's the difference here? 20? 13. Look, are you aware that what is 5 plus 9? What is 5 plus 9 plus 13? It's 29. Huh? Oh, 5 plus 9 is 14, right? Now, plus these 2. So, I'm not going to write my first difference, but what is this? Addition of that will give me what? 14. So, we are saying T1 of the first difference plus T2. If we add that to it, if I'm moving this way, it gives me that. The sum of these 2 plus that would give me T3. Now they are saying 40 of this. Sum of 40 is 3320. Basically, if I add 2 to it, I'll be getting the next term here, T41. Look, are we on the same page? In fact, if you didn't know what to do, you know what I would have done in the example? I would have done this. 2n squared minus n
That's what I done.
plus 1.
Yeah.
Let's be smart, because this is my quadratic.
That's what I done.
And they said this should be equal to what?
3, 3, 2, 2.
3t22. You'll get n as 41 here. So even if you didn't know what to do, the examiner is referring you back to the quadratic. So there's a quadratic term that is equal to 3322. If I want to do a calculation, this is the calculation I will do. Are we on the same page? So, but it's good you learned that beautiful maths thingy. All right. Oh, this was what I was waiting for. This was what I saw in this paper. I didn't do it, but it was just looking beautiful. You're going home. You stuck with me. Yes? What is this? It's geography. This is geography, GPS. What is this? It's geography. Come guys, let's give an attempt.
Please do this one.
No, I can't. Look, you're not going to get me 0. You know your principles of geometric. Apply it. Apply it. They even told you it's a geometric. What do you know about geometric? 3.1 is very easy. Determine the number of terms. Check your formula page. Tn is ar to the power n minus 1. You're done. Come on, papi. What is this? It's Afrikaans. Okay, guys, let's run through this. What I'm sure you've tried whatever you needed to try. The first question is quite easy. The examiner already gave us that it's a geometric. So what I need to ask myself is, what is the formula for geometric? Tn is what? A r to the power what? N minus 1. Let's work with what we know. What is our r, by the way? Our r is always T2 divided by what? T1, which is what? Root 3 over 2 divided by 1 over 2. And that should be what? Root 3. So I already know my r. Now, what is my Tn? Formula? Tn, what is our a? 1 over 2. What is our r? Root 3 to the power of what? N minus 1. Determine the number of terms. Do we know the last term? Yes. So what would it be? If we know, since we know the last term. Last term is what? 81 root 3 over 2. 1 over 2 root 3. Okay, let's do the algebra together. I would actually multiply both sides by what? 2. If I do that, I would have 81 root 3 equals to what? Root 3 to the power of what? N minus 1. Because I've cross multiply already. Now, these are exponents. If I like, I think we can even work without exponents. Do you know that? We can, most of you use logs. Use logs. Okay, I don't want to use logs. I'm stubborn like that. If I don't want to use logs, I need to make sure they are both of the same what? Base. And the base is what? Root 3. Okay. What is 81? Okay, look at this. If I don't want to use logs, I'll use logs. I know you all run to logs. But 3 to the power 4. Now, 3 to the power 4 times 3 to the power half. Because root 3 is 3 to the power half. Will be equal to what? 3 to the power half into bracket n minus 1. I'll multiply if I'm multiplying with the same base, I'll add the exponent. What is 4 plus half? 9 over 2. So 3 to the power what? 9 over 2 is the same thing as 3 to the power half. Since they have the same base, can I equate? So what would I do? 9 over 2 is equal to what? 1 over 2 n minus 1. Can we solve? Alright, so 9 will be equal to n minus 1 and n is 10. Did you get 10? Alright, let's use logs. What would I have done? Huh?
That hurts for me. That hurts for me.
What is hurting you?
I'm saying clap hands for me. Clap hands.
You got it right.
Yeah.
Well done, well done. You see, you're already saying, what is this? Do you see that you could do it? So don't let maths.
Don't betray that. The second one, it did itself.
Okay, guys, look. Now, root 3 is a base. We maintain that should remain what? A base. So that should give you 9. Beautiful. And n will be equal to what? 10. So let's know how to use logs and that. Okay, solve for p. Guys, are you all okay with 3.1? Let me know. Let me know if 3.1 is okay. You are all okay? Any question? We all okay. So guys, don't let math scare you. Just do what you can do and see how it unfolds. Let's see what 3.2. I just saw this paper yesterday and I'm like, oh, nice. So let's see. 3.2. The examiner says that, okay, let me create space. I want to create a bit of space. Solve for P. Again, what is it that we have? Let's check what we have, and that will inform us on how to manipulate what we need to. Solve for P if we have that. Now, the first thing I'm looking at is, I'm looking at this. Whenever I see infinity, I know it's sum to infinity. So I'm going to start from there by saying that alone is sum to what? Infinity. Can we quickly write our formula for sum to infinity? S infinity is what? A over 1 minus R. Let's deal with the left hand side. What is A? A would be what? 9. You see, they said K should be equal to what? 0. So I'll put a 0 there. Anything to the power 0 is 1 times 9. So my A is, please let there be a distinction between your A and your 9. Let it be long. Be conscious about it. Okay. But to get R, I'm going to need T2. Because I know R is T2 over what? T1. By the way, this one is also what? T1. So what is T2 going to be? 9P. I have used the 0. So it goes to what? 1. 9P to the power of 1. What is my R? T2 over T1, which is what? 9P over 9. So everyone should be able to do this interpretation for now. So what is our sum to infinity? What is A? 9 over 1 minus P. Guys, I'm not getting a 0. Are we okay with what I've done on the left hand side so far? Please let me know. Left hand side, is it okay? Sum to infinity. Just take it step by step. Don't do too many steps at the same time. Okay. Now, let's deal with the right hand side. What is the right hand side saying? It says sum of that. I always like for learners to check first what type of pattern are we talking about. Let's get the first term. What is T1? T1 says M should be equal to what? 1. Please just put a 1 on your calculator there and give me an answer.
18.
Sorry? 18. Please, I hope it's okay there. T1, we are simply saying T1, M is equal to 1, right? So T1 is 18. Let's get T2. Please, very important. M now is equal to what? 2. Did you just put it in a calculator? Huh? Negative 12. Okay, I need to get T3 with M being 3. What are we getting? 8. The question is, what type of pattern is this? It's either geometric, or if it's none of the two, then you have to work manually. But let's see, is it geometric? Let's confirm. We have 18, we have negative 12, and we have 8. If it's geometric, what is my ratio? Negative 12 over 18. What would that give us? Okay, what about T3 over T2? Oh, so we have confirmed it's a what? It's a geometric. By the way, what does this thing mean? Sum. And what is the sum of a geometric formula? The formula is there, right? What is it? Sn equals to what? A r to the power n minus 1 over what? The question now is, how many terms do we have? Top minus but plus 1 is still 7. So you were lucky. So n is n is top minus bottom plus 1. 7 minus 1 plus 1, which is what? 7. We're still dealing with the right hand side before I put everything together. What is our S7 therefore? What is A? 18. What's your ratio? Negative 2 over 3. Remember, to the power of what? 7 minus 1. I think your calculator can assist you here.
9.
9 to 6. Okay, that's my right hand side. So the left hand side is 9 over 1 minus p. The right hand side is that. What do I do? Equate. 9 over 1 minus p equals to what? 9 to 6 over what? 81. What do? We cross multiply. Can I ask you to finish up here?
197 over 926.
P is what?
197 over 926.
Please let me know if we are on the same page. It only looks long, but it's very doable. It looks scary, but it's doable. So please don't let maths. I've told you before, if you know, it's just a dog without, the toothless bulldog. Yes? Yes, Michelle, talk to me quickly.
So how did you get 9 over 1 minus p?
Sum to infinity, the left hand side. I just substituted into the remember, this is now my left hand side, which is sum to infinity, and this other part is my what? Right. And so the issue is sometimes you guys do it all in one step and then you get confused. Let's break it down. Left hand side and right hand side. Are we together now? Did it? Okay. So please, if the way we write as well matters, it will help you see what's going on. You're not getting it? Okay. There's a bracket that you didn't put here. 1 second, guys. Just want to see. Yes. When you type it in, type it exactly the way you have written it. Okay. There's one thing I quickly want to show you. Okay, you're writing. Please. The proof. I ask you to do the proof. Did you do it? Please, let's learn to prove that formula. And for those of you that have been following, this is the easiest proof. Sn equals to A, R to the power n. Please, just work backwards, right? That's why you didn't do it. How many lines? 7, 8 lines. And then you jump to the answer. No one is going to know, I promise you. What are you doing? You are now working back where? Upwards. You're reversing every operation. So what do you do here? Cross multiply. What would that be? Sn r minus 1 a. Do you see? It looks like if you divided. What do? Expand. R times Sn. Rsn. Sn times that. Multiply that. A r to the power n. Make sense? Now this is where you need to be smart. You are saying this and this. Also, this is Rsn and this is what? Sn. What is Sn? Sn is usually T1 plus T2, right? T1 plus T2 plus T3 up to what? Tn. Now change it to what? A. What's your T1? A. What's the T2? AR. T3. What's the last term? AR n minus 1. Now what are you doing here? You are multiplying with what? R. A times R. AR. A times AR times R. Because you are saying R times Sn. So you are multiplying all of this with what? R. Basically you are increasing the exponents by 1. AR squared times R, AR cubed. ARN. Equation 1 and equation what? 2. It says Rsn minus Sn. Rsn is your equation 2. So equation 2 minus equation what? 1. We're done with the proof. No one saw you. So you don't cram anything. You just being smart like that. And you walk through. All right. Finally on this one, Guys, please let the practice come in. Finally, on this one, I remember showing you something very important, and I want to just emphasize it again. The relationship between, I want to show you two relationships quickly. I don't want to forget that. For arithmetic, please don't forget this. Do you remember what your Tn is? Tn is Sn minus Sn minus 1. It's not on the formula page, please. Even for geometric, it's the same thing. Even for geometric. So if the examiner asks you to find, remember they gave us one Sn the other time. What was it? Given, let's use that. Sn equals to 2n squared. It doesn't matter anyway. Plus n. If the examiner tells me to find T10, what will it be? I'm looking for 10. My n is 10. T10 will be what? S10 minus what? S9. What do I do to get S10? I just substitute there. Without a calculator, 10 squared, 100 times 2, 200 plus 10, 210. What about S9? Plus n. My n is what? 9. 171. 81 to 162 plus 9, 171. Okay. So what is T10? Just the subtraction of that. Alright? So T10 would be what? 210 minus 171. 29. How can it be 30? 10 minus that is 9. You are left with a 9. 29. So please, that formula is not given on the formula page. It's something that I need you to know. You sure? 39. So, because of that too. In an exam, when they say start writing, quickly put that on your formula page. Add it to it. Right? So let it roam in your head. You're just waiting for start. I know that 1 hour is like a mess. There's no hour that I hate like that 1 hour. Second relationship is this. We know that Sn is what? A r to the power n minus 1 over what? And this formula can be written as this as well. It's the same thing. Please look at what I have done. I have switched the 1 and the r. It's the same. When I was proving earlier, I said 2 minus 1. If I had done 1 minus 2, I'll get the second part. I promise you, if you put any value here, you would get the same answer. But the trick here is this. If I am starting with r here, I must start with r there. If I'm starting with 1 here, I must start with 1 there. Why am I showing you this? What is your sum to infinity? A over what? I want you to see your sum to infinity here. So, what is your Sn? Instead of writing all of this now, I can simply write. When do you use this? When an examiner gives you Sn, they give you S infinity, and they're asking you to calculate R. It's 6 marks. But if you remember this formula, you shorten this. Actually, it's a simultaneous equation. But with this formula, you shorten it, it's full marks. This is hashtag crazy physics. Eh? It's not, yeah, we must pattern it. You'll see it somewhere. Somebody says, guys, I discovered it. Calm down. Please, this is very, very, very important. Just so I'm running out of time, I will have shown you. But can we try one question? We can create a question. We can create something together. Let's create something. We can. Oh, wait, let's use the previous one. There was one that, no, but it has so many roots. But it's fine. We're math learners, right? So let's use it. Where is it? This one. Let's use this one. I'll use question 3.1 to do what I want to do. 3.1. So, an examiner would go at the back end. Let's check something here. How many terms did we have here? We got 10, right? Okay. Guys, do you want to quickly get me the sum of the first 10? This is what the examiner is doing at the back end of the screen, which I do want to show you. What is Sn? A r to the power n minus 1 over what? So it's half. What is r to the power? What is our r again? Root 3. All right. Root 3. Ooh, I hope it doesn't give us some. What is this giving us? Quickly, please. We're running out of time. What's it giving us? Give me the simplified version, fraction or something. What are you getting?
165,29.
165?
12890.
Which I wanted something that we wouldn't have to round off. Okay, hold on. Just permit me to create it. I want to show you how that formula works and what you'll be doing. Let's start with 2. Our ratio is half. What is 2 times half? 1. 1 times half? Half. Times half? 1 over 4. 1 over 8. 1 over what? 16. Okay. 1, 2, 3, 4, 5, 6. Please give me S6. You can just add them together on your calculator quickly. S6. And then I want S infinity. I want to create a question. So you are helping me create a question now. What is 2 divided by half? 4. What's the first one? 63 over what? Okay, now guys, you don't know this left side. It's in the examiner's diary. Look at what they send you through your DBE. The examiner now says, the sum to infinity of a geometric series is 4. The sum of the first 5 terms. Oh, no, not 5. 6 is what? 63 over 16. Calculate R. Now, this is the first thing that comes to Elena's head. Elena says, okay, they've given me sum to what? Infinity, which is what? S infinity, which is what? A over 1 minus R equals to 4. This Lena knows nothing else. So this Lena only knows that what? A over 1 minus R is 4. Equation number what? 1. So if you don't know what to do, transcribe everything into maths. Then they told this learner that the sum of the first 6 terms. Okay, so this learner knows that Sn equals to what? A r to the power that S6. So 63 sum. This learner does not know A. Alright. This learner does not know R. But this learner knows that N is what? 6 minus 1 over what? R minus 1. This learner now has how many equations? 2 equations. This learner then decides, okay, I am going to find the value of A on the left hand side. What is A? 4 into 1 minus what? R. And then this learner decides to bring in A here. Do you see what we're doing? To say 63 over 16. Instead of writing A, this learner now says what? 4, 1 minus R. R to the power. Okay, it's even nice that I'm doing this. Should you come across something like this? Now look at the top and the bottom. The 1 minus R is very similar to R minus 1, but it's a sign change. So what do I do to solve this? 63 over 16 I am going to multiply the top by 4, by negative. Once I do that, I am allowed to do this. I don't know if you notice what I did there. So that this can cancel that. But I cannot cancel if I'm not introducing that what? Negative 4. This is so long, but this is what Elena is doing. Beautiful. Elena is interpreting. So what do we have? 63 over 16 equals to what? Negative 4. What would this Elena then do? Divide both sides by negative 4. What would that give you? Negative 63 over 64. R to the power 6 minus 1. What would this learner then do? Move the 1 over. So this learner would be getting what? I just want to move it here. R to the power what? 6. 1 over 64. Then this learner will look for what? The 6th root of 1 over what? 64. Which will be plus or minus 1 over what? 2. Why plus or minus? It's an even root. Okay, guys, beautiful. I clap hand for this learner. This learner has done well. Let me see if you understood what I did, guys. It's a question of interpreting step by step and taking yourself through gradually. What's next? You're just solving. Are we on the same page? Let me know. Okay. But a learner who has been through these sessions would know that, okay, I have S infinity and I have Sn. Okay, guys, don't waste your ink. Why are you writing all of this? No way. This is a learner who has not been exposed to us. But a learner who has been exposed to us would remember that, okay, this crazy human being said that if I have S infinity and I have Sn, there's a formula that links them together. And what's that formula? You quickly do it again. Oh, this one is what? A over, don't cram it. What is this? A over, do you see 1 minus r? So I'll use that one. And this is sum to what? Infinity. Okay, so check. Sn is S infinity. Don't you see that life is better? Sum to of the first 6 terms. What is it? 63 over what? 16. What is the sum to infinity? 4. 1 minus r to the power 6. I don't know if you see where we are already. Divide both sides by 4. 63 over what? 64. 1 minus r to the power 6. Switch the things. If I move r to the power 6 over here, and 1 minus would go there, right? Look at that and look at this mess. In fact, you get discouraged along the way. You say, I don't even know if what I'm doing is right. So please learn that formula. It's a relationship that I need you to learn. Are we okay, everybody? That makes sense? So please don't forget. And don't cram it. Just know that, oh, there's a relationship. But my S infinity is 1 minus r. So I go to my Sn and change things around and rewrite it. I'm hoping it comes out. Huh? Say, I'm hoping it comes out. Okay. So you get 6 marks. Pa, 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 pa. All right. That was a beautiful question. There's something I'm going to show you within functions and calculus, right? There's something I want to show you on this paper. But let's quickly look at probability and, yeah. How many marks here? 14. Okay. You don't know probability? Please, you need to learn it. Let me give you a crash course quickly. What do I need to go into the exam with when it comes to probability? Just about 3 things that you need to know. Number one, mutually what? Exclusive. What does that tell you? Probability of A and B. Every time I think about this, I just think of my X. I have nothing to do with them. Zero thing to do with them. Okay. Some of you are not like that anyway, but it's okay. Number two, what's the next one? Independent events. What do we say? Probability of what? A intersection B should be probability of A times probability of B. Number three, complementary events. That one is always very straightforward. Probability of A plus probability of not A is equal to 1. It's either it rains or it doesn't rain. All right? Then the last one is given on the formula page. Number 4, probability of what we call it, what's the name now? I've forgotten now. But probability of A or B. How can the name just run away? Probability of A plus probability of B minus probability of what? A and B. These are the main things. And then you have your tree diagram, you have your Venn diagram, contingency table. I pray they bring you a contingency table. That's the easiest. Your tree diagram can be hectic sometimes. But anyway, if I know this, I'm just going to apply commutative rule here. No. It's the additive rule or addition rule of probability. Because we are saying or is a plus. Addition rule. So the first three are not on the formula page. But if you can just remember the first two. Because once I say not, I know it's 1 minus. It's like you're sitting together and not sitting together. We would look at all of those. Okay, let's try this. Events A and B are independent. Please don't forget what that means. Once I see the word independent, what do I know? The probability of A times the probability of B must be equal to the probability of A and B. Represent the given information on a Venn diagram. Indicate on the Venn diagram the probability associated with each region. Let me give you 2 minutes to try. Please try. Try. You know what a Venn diagram looks like? It's 2 circles. So these circles are intersecting. Okay, were you able to draw? Independent events. I have A. Please, the whole of A is what the examiner meant by 0,3. And the whole of B is what the examiner meant by what? 0,6. Because these events are independent, What is probability of A and B, the intersection? 0.18. By that formula that I wrote on the board there, because this is A and B. So this gives us what? 0.18. I hope you all know how I got that 0.18. It's 0.3 times 0.6. Now, the whole circle here is 0.3. But this small part is 0.18. What will this one be? So it's 0.3 minus 0.18, which gives us what? 12. The same thing will happen on the other side. What is the other side going to be? 0.6 minus 0.18. What would that be? 0.42. And this one here, this 0.12 is actually A what? Only. The 0.42 is B what? Only. But do you think we are done? Could there be something outside here? Possible. How do I get that? 1, 2 plus 1, 8 will give us what? 3. 3 plus 0.42 will give us what? 0.72. The entire probability should be equal to what? 1. So what is 1 minus 0.72? May I please ask if we are okay with all the figures here? Please let me know. And each of the region. Each of the region. Let me see, please, quickly, who is not okay? So please try to also write what I wrote down. A only, note the regions. A only, B only, C only. What is this 0.28? It is not A or not B. So what would that be? Probability of A or B. Because it's 1 minus. Oh, 10.1.2 is already done. What is B only? 0.42, 1 mark. What about B, not A? B, not A. What did you say? It is B, but we don't want it to be what? No, B or not A, rather, sorry. B or not A. Let me show you something. Maybe this would help. Let's see if we can get it like this. Remember what we said probability of A or B is, right? It is A or B minus A and B. Let's try if this would help you to see. This is going to be probability of B plus probability of what? Not A minus the intersection. Guys, don't be surprised. I am only using this formula. Probability of A or B. I wanted to do something. It's probability of A. So I'm just following the same formula. If you cannot read it off the chart, let's try to see if we can use that formula. I'm just replacing A, not B, da da da. What is the probability of B? 0.6. Probability of not A? No. Probability of A is 0.3. Not B only. They said probability of not A. Probability of A is 0.3. So not A will be what? 0.7. We good? What about the intersection of B and not A? Let's go to the graph. Where is it not A? Huh? Not A only. Probability of A plus probability of not A is 1. That word only changes the whole thing. Okay, guys, let's see. What is this? Where is probability of B? Probability of B is here, right? Keep an eye on this. Is that fine? Where is the part that says not A? Again, this is probability of B, right? Okay. Which one is A? This is A, right? Where is it not A? It's only this part. Does that make sense? Again, what is probability of A? This. Do we agree? Where is it not A? Anything that is not in the circle. In fact, all of this and outside is not A. Make sense? Not A. But where is probability of B? Probability of B is this. So where is the intersection between those two circles? It's just here. That is what is common to the two circles. Let me let my flashes go. I want to repeat that. Just one moment. It may take some time now because I was writing. But I don't know if it makes sense though. Look, we are here. We're saying, what is the probability of B intersection anything that is not A? What is common to them? Okay, this is taking extra time. Probability of B is this. Which one is not A? All of this. Can you see the intersection? That the intersection is only 0, what? 4, 2. What's your answer? Zero comma? So that is a way to see if you are not sure.
So you can't just say that 0,42 plus 0,28.
0,
42 plus 0,28.
if you read it nicely, if you know how to, no, not 4, 2, and 2, 8. Yes.
Can't I say the probability of B or not A is 1 minus the probability of not A?
1 minus, yes. 1 minus probability of not A.
You're saying 0,6 plus 0,28.
Guys, talk to me quickly. Anybody saying something there? Basically, they are asking you for what is not A. Yes, Naledi?
So, I don't understand why you're not adding 0.28.
Why?
I'm not adding the 0.28.
All right. Why are we not adding the 0,28? The 0,28 is not part of B. Isn't it? I'm looking for what is common, right?
Yes.
What is the probability of B? This is just probability of B. Are you with me there?
Yes, sir.
Okay, what about not A? Not A is everything else. Do you notice the 0,28 is not A, but it's not part of B? I'm looking for intersection. This is the only thing that is common. Let me do this. Maybe it will help you quickly. Don't let me use flashes. Okay, check this. We want to find what is common, right? Okay. What is not A? I'm going to use a green marker to show what is not A. Not A. Please let me know if you agree with not A.
Yes, sir.
Do we agree with not A?
Yes, sir.
Okay, beautiful. All of this green part is not what? A. We're good. What about probability of B? Let me use a light blue. Probability of B is that circle of B. I don't know if that's visible enough, or let's use a yellow one. Oh. Look at probability of B. It looks like the human eye. Where do we have both yellow and green? Where do you think? Both yellow and green. Can you see it?
Intersection. Yes, sir.
Intersection. So if you're doing life science, when you do the human eye, that's what they're asking. Did that make sense now? So if you are not sure, because those things can be confusing. So that's why I like to break it down and expand it. All right. Beautiful. Lovely question there. Let's see. We're going to look for one or two more. But I want us to deal with counting principle quickly. Part of probability. And this one is a code. Oof. The digits 0, 1 to 7 are used to create 4-digit codes. Please give me the first one. Everybody must get 1 mark. 1 mark. How many different codes are possible if the digits may be repeated? Digits may be repeated. Can we share answers? I want us to have an interactive session on this one. How many codes? It's a what? A 4-digit code, right? So if it's a 4-digit code, 1, 2, 3, 4. You are all wrong. You are saying 7 factorial.
No.
So how many numbers are possible in the first part? There are 8 digits, right?
4,096.
Okay, no, before we get there, can we what did you multiply? Let's get what you multiplied. 7 to the power of 4. Why 7 to the power of 4? But how many digits do we have? So there are possible 8 digits there, right? Right? Next digit, 8. Next one. So it's 8 times 8 times 8 times 8. What's your answer again? Michelle, what did you get?
So 4,096.
All right, that's a correct answer. Okay, let's go through a second one. If digits may not be repeated, how many different codes are possible? Try that quickly. You have 30 seconds or 1 minute. If digits may not be repeated, how many?
40,300.
How can it be 40,000?
Oh, wait, no. Oh, but it's a 4-digit code.
4-digit code. Guys, can I please have conversations going on here? Zolunga, what's your answer? Huh? What's your answer? Didn't you talk to me? 1,680. What do you have? Why?
I don't get the counting principle. I don't understand.
Okay, do you understand what we did on the first one?
On the first one.
Okay, look at the second one. How many digits? How many? 4-digit code, right? 1, 2, 3, 4. Digits may not be repeated. In the first spot, how many digits do I have to use? 8. I could use from 0 to 7. So let's say I've used a 0. How many are we left with? 7 digits. How many are we left with now? 6. And how many are we left with? 5. You just multiply. So this gives you what? 1680. Done. Make sense? Calculate the probability. Please take note. It's now probability. You will never answer it. Let's do it together now. That a code will be a number between 2,000 and 6,000 that are divisible by 5. It's a lot of stories going on here. You've got to do it step by step, please. Okay, let's forget the fact that it's a probability. Let's leave that one out. The code must be between 2,000 and what? 6,000. But don't forget, may not be repeated. If this number has to be greater than 2,000, I cannot start with a 0 and I cannot start with a 1. Does that make sense? Because if I start with a 1, how is it greater than 2,000? There are 4 digits. So what numbers am I likely to start with? 2, 3, 4, 5, 6, 7. Please watch closely. Oh, no, wait. They said it must be between 2,000 and 6,000, which means I cannot start with a 6 even. Because once I start with a 6, it's greater than 6,000. Are we okay, everybody? Let me know if that first line makes sense to you, everybody, quickly. I don't want to come back. We're dealing with the first part. It must be greater than 2 and less than 6. So my possible options are 2, 3, 4, and 5. Okay. But it must be divisible by what? By 5. For a number to be divisible by 5, the number must end with 0 or 5. Are we okay? Look, this is my first layout. Once you see that you have a 5 and a 5 here, that is the big announcement of a problem. Why? Digits may not be repeated. I'm going to now pause. So what I will do is, because that 5 is giving me a problem, I will then decide. Let me go to a new page. We said 1, 2, 3, 4, right? 2, 3, 4, 5, 0, and 5. This is my problem. I will then decide. Let me start with a 5. Or let's see. If I start with a 5, it means I cannot end with a 5. Or let me do this. If I have 2, 3, 4, since 5 is a problem, my numbers can end with 0 and they can end with a 5. Does that make sense? Please give me thumbs up and thumbs down if you understand my new statement. That if it's starting with a 2, a 3, and a 4, yes, then I'm allowed to end with what? A 0 or what? A 5. Digits may, I have not repeated any digit. Now, what are my options? How many options do I have here? I only have 3 options, which is 2, 3, and 4. Right? How many options do I have here? 2. The whole set is 8. I'm moving from 0 to 7. But I have used how many? I have used 2 numbers. How many numbers am I left with? 6. So this would be what? A 6, and this would be a 5. Let me know if this makes sense. I want us to explore quickly. Quickly, guys. Talk to me. There's some good marks here. This is me starting with either a 2, a 3, or a 4. Then I know I can end with a 0 or a 5. So the fact that I am starting with a 2, a 3, and a 4 tells me the number of options. There are 3 options. There are 2 options. Now check. If I use 2 here and I use 0 here, I'm only left with 6 numbers out of 8. That's where the 6 came from. In all of this, I will now say, okay, since I didn't start with a 5, let me now start with what? A 5. If I am now starting, because 5 was my problem, let's now start with a 5. if I start with a 5, I can only end with a 0. I cannot end with a 5 again because digits may not be repeated. So I have one option there, I have one option there. I have used 2 numbers, I have 6 and what? 5 options. This will be 30. And what would that be? 10, 18, 180. Together, 210. So there are only 210 numbers that I can create between 2,000 and 6,000 that are what? Divisible by 5. So please break down that option. Once you see that it's appearing twice, break it down. But the examiner is asking for what? Probability. So probability therefore will be 210 over our sample space. Don't go to the sample space of A. Go to the sample space if digits may not be repeated. 1680. Simplify your answer and we're done. 0,125. You can try now. It's just a matter of you being patient here. You got to be patient. Yes, talk to me. You've got to be patient. Yes, Naledi?
So, can't you also say, for the first one, can't you also use like 5 and like other numbers like 2, 3, and 4? And in our option, we have 4 options.
If we wait, can't we start with a 5, right?
So I'm saying, can't our first like digits, can't we say like we have 4 options?
What?
Looking at the fact that we can use 5, 2, 3, and 4. And then say
You want to put a 5? You want to put a 5 here?
Yes.
Don't do that. Please, don't.
So here you do that, but then you take out the 5 at the end.
Yeah, guys, it's complex. Even I don't want to even think about it. You will forget something, I promise you. You will forget. You will. Please, once you see that 5 is like it must end with an odd and an even, break it down to say I'm starting with odd and I'm starting with even. Because once you say you want to combine, you are likely to miss something. So now, lady, please break it down like this. Are we together? Please. Let's go look for probability from another question. Yo, you were writing? Okay. Let's try another probability from a different question. Hopefully we can get something else. I want us to do together and not together. Where should we go? How 10 people, they were trying to show off. They set a question that is a combination, not let's see. The Eastern Cape paper here is not so clear. I would have loved to look at it. Oh, this is a Venn diagram, right? Yeah, a Venn diagram. Oh, let's look at this mathematician. Let's look at this one quickly. Let's try. Guys, I want us to think together. Consider the letters of the word mathematician. The letters that are the same are treated as being what? Identical. If the letters are arranged in any order without repetition, what is the probability that the word arrangement form will end with the letter what? M. Okay, quite tricky. But let me start first. Let me do so many questions on this. If I just give you the word mathematician, how many possible arrangements? I'm not answering the question yet. I want to do the basic one. How many letters do we have here? Mathematician. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this will be what? 13 factorial over. How many M's do we have? How many M's? 2 M's. How many A's? 1. Stop lying. 1, 2, 3. 3 A's. What other letter is repeated? How many T's? 2. How many? There's only one H, right? E, I. How many? 2. You put this in a calculator and you get an answer. That's the basic entry level. Whatever is repeated is a denominator and you divide. Basically, you are removing them. But look at this question. The examiner says that they want it to end with what? M. Okay. If it has to end with M, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It has to end with M. How many options? End with M. 1. Okay. Letters are identical.
Yes, it's not M1 and M2.
It's not M1 and M2. It's M. So there's one M. The other M is going to be playing around. Yes, talk to me. Let me.
So,
Yes.
what do they mean by the letters that are the same are treated as being identical? So, what do they mean by that?
They are treated as, for example, check this. If I say BOO, the O's are identical. Okay, check this. If I say O1, O2, it means it's a different O now. Which means I can write BO2, O1. It's not the same. Because I'm spelling, so if I'm spelling, I say BO2 and O1. They're not identical. But if I say they are identical, check. It's the same word. So I'll have to remove this. Does that make sense?
Yes, sir.
Huh?
Yes, sir.
Okay. So when they are identical, because they are identical, that is actually why we are dividing. You see this? It's because they are identical. If they were not identical, I won't have this denominator. Same page? Lovely. Okay. So M is here. 1. How many letters will I have playing around? There are 13 of them. I have already fixed M there. So what will I have here? 12 letters. Followed by 11. Followed by 10. Followed by 9, 8, 7, 6, 5. Do you see a factorial there? Do you see that that's 12 factorial? Okay. 12 factorial times 1. Guys, I have to remove the repeated letters again. Because it will be the same word. Which letters are repeated?
A.
How many A's do we have? 3 A's. How many T's do we have? What else? I. Is it making sense?
So we don't account for the 2 M's.
Good. Now, what happens to my M? I have to account for it, because if I start with M1, mathematician, and the other M is at the end, and I swap them, I'm still writing what? The same thing. So I'll come here and account for that M as well. I was waiting for that. You see, what's going to happen to the M? Because it's M1, M2. Are we okay, guys? Did it make sense? So every time we divide, we are accounting for what? A repeated letter, because we want to cancel it. I can show you the meaning of that denominator quickly. I like doing this when I start. Okay, let's look at boo. Give me other arrangement. BO2, O1, right? Then what do we have? O1, O2B. O2, O1B. What's next? OBO. OBO. 1, 2, 2, 1. I should have 6. Right? If they are different. But if they are identical, then this should go because I already have this. If this stays, which one should go? This. If this stays, this one should go. So how many letters? How many arrangement? 3. Let's do it mathematically. How many numbers do we have? 3 factorials. How many O's? 2, which is 2 factorial. If you do that, it will give you 3. That's why we divide to take care of identical what? Letters. I hope it makes sense. Let me know if it makes sense to everybody.
So it comes to questions like this. You just sort out what they ask for first, like M at the end.
Yes.
And then you just go into order.
Always sort out what the restriction they are giving you. Then, okay, I'm going to look for more. Guys, I'll leave Venn diagram. That one you must be able to deal with. Come, let's go for... Yes, talk to me quickly.
So,
Yes.
how would you do it if they said that you should not treat them like they were identical?
Then all the,
Yeah,
the denominator will not appear. That's all. Just remove the denominator. That's all.
Okay, sir.
Yeah, so it's normal if they say they are not what? Identical. We just remove that denominator. That's why that one will have given, the BOO will have given us what? 6 by saying 3 factorial. Let's try Limpopo. Limpopo. I'm seeing something here very nice. Guys, I did this. I think I did this in my 1.4s. I did. Please, I'm not going to do it again. This will force you. I need to force one more view from you on. Yeah, I did it. Please go look for me on what? TikTok. This one is fine, right? Will this be a problem? Okay. Please let me know if it's a problem. We are doing functions. Woo! Oh, do you guys remember that? Can you change that to that? 4.2.1, 2 marks. Okay, I'll do it on Thursday. Let's just do it now. X plus 3 over what? X plus 1. Do you see that answer that they got? Okay, so X plus 3 over what? It's my new method. What's my asymptote? Vertical asymptote. Vertical asymptote, X plus 1 equals to 0. So what is X? Negative 1. Look, I'll then say A. Anywhere I see X on top, I'll just put negative 1. Negative 1 plus 3. What's your answer? My A is 2. So my new equation therefore is what? 2 over. Now what is the coefficient of X here? 1. Should we try one with your long division? Check, bro. 2x plus 3. I'm the one who taught you and I just scrap it. Do long division here.
It's too long.
Too long, bro. What is your vertical asymptote? X equals to 1. Substitute it there. 2 times 1 plus 3. I'm done. What's the coefficient of X there? Done. Case closed. Next. I can do 300 of this in 3 hours.
How to get the plus 1?
Yeah.
Which one? The coefficient of X here. That's what
So
you
how
do.
did you get R?
How did I get what?
I mean, I get how you got A, but I don't get how you got like 1.
The coefficient of X. Check these two. It's the coefficient of X.
And it just brings down.
So you just get coefficient. What if it was negative? You got a minus.
Check, Papi. X minus 2. What is your vertical asymptote? X equals to 2.
2.
So you
Yes,
substitute 2 there. So what is 2 times negative 3? So please just show examiner, because if they say show, you have to, because they won't understand what you did. So show them that my vertical asymptote x equals to what? 2. Therefore, A is negative 3, 2 plus 4. What will that give us? Negative 2, right?
Yes.
Are we okay? So what's my answer?
Yes, sir.
Negative 2 over what? X minus 2. What is the coefficient of negative 3?
Minus 3.
We are done, Papi. Lovely. Are we good? Ooh, I'm loving that smell of the rain. And that smell is therapeutic. I must buy a perfume that smells like that. It must be there. Rain dust. I'm going to look. If it's not there, I'm going to create it because it's an ester. Okay, come, let's try this one before we shut down. But I hope that, guys, it's been quite productive for you. It must be quite productive. Okay, let's check this. Let's try this together. 4-digit codes, not beginning with a 0. So they're very specific on this one, right? Are to be constructed from the following set of digits. Okay, although there's 0 there, they're saying it must not start with a 0. How many 4-digit codes can be constructed if repetition of digits is allowed? I'll give you 30 seconds. Let's try. It's a 4-digit code. Repetition is allowed, but don't start with 0. Please write down, Shamil. Don't do it in your head. Don't do it with your head. You have 25 seconds left. If repetition of digit is allowed, we should be done, people. 4-digit code. I cannot start with a 0. So what are my options? 1, 2, 3. Hey, be careful. There's no 5. Be careful. There's no 5. They want to catch you and they caught you. Even me, I said 5. But I was smart enough. So please, you see the things that they want to do, right? So it's 1, 2, 3, 4, 6, 7. This is just being evil, though. I mean, why would you just remove 5 there? So how many numbers do I have? To even count is difficult. To count 1, 2, it's like. Wait, you know what they're doing? It's like this. Check this. Which one is red? The blue is red. That's what this examiner is doing. But anyway, 1, 2, 3, 4, 5. Your brain must disagree a bit. All right. 1, 2, 3, 4, 5, 6, 7. So our first one, we have what? 7 options. Why 7? I cannot start with what? A 0. Now, if digits repetition is what? Allowed. It means now I can use all the numbers again, including what? 0. So how many options do I have? So it's 7, 8, 8, and 8. Can we start attempting now in a paper? We're getting there. Okay. Please remind me when we meet on Thursday, I need to do together and not together. These are very important. What's your answer here? 3, 5, 8, 4. Number 2. How many 4 digits can be constructed if, answer that for me now. If repetition of digit is not allowed. Please remember, we still cannot start with what? A 0. Come, Noe. Oh, you're done? Okay. 1, 2, 3, 4. What's your first option? It's still 7 because I still have 1, 2, 3, 4, 6, 7, 8. 7. What about the next one? Is it 7? You sure? Okay, it cannot be 8 because now they said no repetition. So I only have 7 because I've already used 1. So I have 7. Next, 6. Next, 5. Same page? Alright, 49 times 3 would give you what? 49, 3 zeros, that is 27, 2, 4. 4 times 3 is what? 12, 1, 4, 1, 4, 4, 0, something like that. 1, 7, 0. Okay, not bad. Calculate the probability. Remove that word first. Of randomly constructing a 4-digit, which is divisible by 5 if repetition of digit is allowed. Wait, look at this. If it has to be divisible by 5, it can only end with 0. There's no 5. But then they said repetition of digits is allowed. But still, I cannot start with a 0. What are the numbers? 7. Are we together? 1, 2, 3, 4, 6, 7, 8. 7. This one is 1. Okay, give me the next spot. Huh? Okay, I have 7, I have 8. Which one is correct? The next spot. Digits may be repeated, which means I can use all the numbers. Next one, I can use all the numbers. What would that give you? 64 times 7, 4, 7, 28. So we have 8, 2, 56 plus 2, 588. Yeah? 448. Oh, I'm beginning to be bad now. 448. But now, this is just the number. The examiner says what? Probability. So the probability will therefore be what? 448 over what? We look at it if digits we look at if digits are repeated. Don't go and bring if digits are not repeated, because right now, no. What are we looking at? We're looking at the one that says what? Repetition of digits is allowed. Where did we do that? The first one. What was our answer? 3584. Please simplify that. 0, 1, 3. Yeah, one. You said 125. I knew that you were just. He likes those percentages. Guys, did it make sense a bit? We're getting there. We're getting there. So at least now we can approach. Please remind me, we do together and not together, functions and optimization.
Hi, sir.
Hello.
Thanks. 0.125.
Yeah, 0,125 is 0,13. Maths, 2 decimal places.
Oh, sorry.
Eh? 1 over 8. Yeah, you can write 1 over 8. So remember, maths, 2 decimal places. 125 is 1, 3. All right, for those writing tomorrow, good luck. For those not writing tomorrow, please work. Don't sleep. We work. Good night. You're writing maths?
No, I'm asking those who are writing tomorrow. I can write maths.
How can they write maths? It's a national paper, bro.
Yeah, that's what I'm asking.
For those writing any subject tomorrow, look what.
Someone to be specific. I think now you're confusing.
How can I confuse? I said for those writing tomorrow. Definitely it's not maths. Okay, good night, Luke. Leave it. Bye, everybody. See you again when we see. All right. Bye, guys.
Trying to get some sleep.
Bye-bye.
Get some sleep.
Huh? Yeah, I will. Good night. Luke, good night. Go and sleep. Bye-bye.